Good evening, students. Pushti sir again here to give you some more interesting questions. We'll discuss today a very interesting problem in electric dipoles. Are you all aware of electric dipoles? Hope so. You must be knowing the basics of electric dipoles and the proper terminologies. Anyway, before I proceed, this is my credential written here. If you want to contact, I give you a contact number also, because we are going to have a very long-standing relationship henceforth, while continuously giving many number of very important concepts to you, which will help you gain confidence in physics. Okay, let's proceed. The question is a point electric dipole. What is a point electric dipole? The distance between the two positive and negative charges and the point where the effect is studied, the distance of the point where the effect of the dipole is studied, and the distance between two point dipoles. This will decide is a point dipole or not. That means if this is a point dipole minus Q plus Q, this is L, and I'm observing the effect at a distance at a point P, which R, and R is very much greater than L. This is known as point dipole. How much greater? At least R should be 100 times more than L as a thumb rule. Okay, I think you are aware of this concept. So this is a point dipole as far as the point P is concerned. So that's what I'm saying. The point electric dipole is kept fixed at the origin, which is dipole moment pointing along positive z axis. Let me show the diagram. Yes, this is xy plane. This is z axis. Point dipole kept here. Is dipole moment is pointing along z axis. Okay. And this is fixed also at the origin. And a particle having mass m and charge q, there's a particle here having charge q and mass m, is attached to the point dipole with the help of an inextensible string of length L, let us say. And it is released from there. It is released where? You see how it is kept on the xy plane. The point charge is kept at xy plane, the particle. So from the xy plane, it is released. Release means without any initial velocity is released. And the string is stopped. Just stop. The most important point here is gravity is absent throughout this space. There is no gravity. The question is describe the motion of the particle after being released, and what is the tension in the string when it is becoming vertical, when the string becomes vertical. When the string becomes vertical like this, what is the tension in that string? First, we take a revision of some of the electric dipole concept. It's a point dipole, as I told you here, P bar, and R is from the dipole. So R is, as I told you, much greater than the L. L is the distance between the two point charges, minus Q plus Q. Much greater R. Okay, point dipole. So what are the fields in radial and tangential directions? You must be aware of this. 2 1 by 4 pi epsilon 0 P by R cube cos theta. R cap is the field in R cap direction. Field in this direction, I call it ER. ER magnitude is this. 2 K is 1 by 4 pi epsilon 0 P by R cube cos theta. Similarly, what is tangential direction field? The theta cap unit vector, we call that. That is only 1 by 4 pi epsilon 0 P by R cube and sin theta. This we know. And potential at that point A is how much? Very simple. You all must be knowing. K P cos theta by R square, or K P dot R by R cube. Okay, this is the potential. Yours. All of you clear or not? Must be knowing this. Now, the situation I'm redrawing again. Here, the situation. So, at this instant, theta is measured from where? Beta, follow. Theta is measured from the direction of angle between measured from the direction of P bar to R bar direction. This is P bar, this is R bar, so this is theta. So in our given situation, this is my theta right now is 90 degree. At any other point, let the theta be, it will come down, because see, at this, what is the field direction? Gravity is absent, remember. Field direction will be opposite to this is the perpendicular bisector direction, theta 90 degree, and obviously P bar will be opposite to the E bar. ER will be 0. Thus, see this cos 90 is 0. This is only sin theta sin 91. Only E theta will be present, and that is in theta cap direction. So this is theta is measured from here. So theta cap direction is this. E is pointing theta cap direction, as I told you. This is the theta cap direction. Am I clear? So then what will happen? This field will try to push it down because the charge is there, Q. So as it starts moving, the string will not allow it to go any random path. It will be, string is inextensible. It will try to maintain in a circular path. Let's assume that string has a role to play here. This is my assumption right now. Right? So as it moves, ER will start building up because theta becoming more than 90. Then E theta, again look at this. If theta become more than 90, cos theta will become negative. So in a negative R cap direction, your radial field will point to. So now let us say this angle is alpha. So theta is how much? 90 plus alpha. Alpha is this angle by which the dipole string has rotated from the original orientation, alpha. So what is theta then? Theta is the angle between R and dipole moment direction, which is Z direction. So that is 90, theta is 90 plus alpha. Okay. So what is the ER? 2 into K 1 by 4 pi epsilon 0 P by R cube cos theta, and cos theta is 90 plus alpha. 90 plus is minus sin theta, sin alpha. This is sin alpha. So 2 P 4 pi epsilon by 4 pi epsilon 0 R cube sin alpha minus R cap. Minus R cap towards the center. That is pointing to. E theta is Kp by R cube. Sin theta is sin alpha. Sin 90 plus alpha is, that is, this is, my bad. This is cos alpha. Right? So P cos alpha by 4 pi epsilon R cube theta cap. Theta is the unit vector perpendicular to R cap. So what it means? The speed of the particle increases in the first quadrant. Why? Why should increase? Because there is a tangential force. So speed will increase. So as theta is equal to 180 degree means when it is vertically down, it will have the maximum speed. That's what I wrote. Why is it maximum? Why not go up again? Because again, the once it crosses this quadrant, theta will become more than 180 degree. More than 180 degree means E theta will become, it will become which direction? Cos alpha will become more than a, so negative theta cap, that's opposite to this direction it will become. So the speed will start decreasing after crossing this lowest point. That's what we are observing. These are the observations. So E theta will become, so then the E theta will become in negative theta cap direction. So the speed at the of the particle decreases in this second quadrant as it goes to the left quadrant. So the speed of the particle decreases second quadrant, but ER always points towards O. So this sin alpha minus R cap, R is alpha is from here to here. In these two, both the two quadrants, sin alpha will be ranging from 0 to 180. So they will be positive, or sin alpha will become positive. A minus R cap, it will remain. So always the whole quadrant, these two quadrant, sin this ER will be towards center. Always negative R cap. That's what I wrote. Okay. So that's what I have written in this. So V as position 2. Here position 2, this is position 2, this is position 1. I have written here position 1, position 2. So what will be V at position 2? V at position 1 will be 0. Why it is 0? Why should it be 0? Because theta is 90 degree at position 1. So cos 90 is 0. So V at initial position is 0. So V at this position 2 is how much? Let us see. P K P by R square into cos 90 plus alpha. So that is minus 1 by 4 pi. So P sin alpha by R square. This is my equation 6. Equation 4 is the ER. Equation 5 is the E theta. Equation 6 is the potential. Okay. So basic equation 1, 2, 3 is there. Right. Now there is no non-conservative forces doing work, any work. If tension is non-conservative, not doing any work, because it's always perpendicular to the velocity direction. So we can conserve energy at position 1 and 2. So from energy, the P1 is 0. K1 also 0. It is released from rest. That's very important. Then P2 is minus 1 from equation 6, minus 1 by 4 pi epsilon 0, P sin alpha by R square into Q. This is the potential energy. K2 is half mv square. V is the velocity at position 2. So 0 plus 0 is P2 plus K2. So from this I got mv square is this much. Yes or no? So what is the electrical force then in radial direction? EF electrical in R means radial direction. How much? Q into ER. ER is how much? 2 into Kp by RQ sin alpha from which equation? Equation 4. You see it again. This is the equation 4. Okay. Into Q multiply, that give you force. Exactly, that's what I wrote. 2. This is the ER. This is Q. Tension in this thing, let it be T minus R cap direction. Tension auxiliary pull force, as you know. So what is centripetal force? Is electrical force plus tension force. That must be mass times acceleration is v square by r. So mv square by r. Okay. इक्वेशन 7 से हमको क्या मिल रहा है? mv स्क्वायर को मालूम चल गया अभी एनर्जी कंजर्वेशन से, डिवाइडेड बाय r कर दो, ये r क्यू हो जाएगा. दस एग्जैक्टली व्हाट आई रोट देयर इन दिस राइट हैंड साइड. 2 kp r क्यू is equal to mv square by r from equation 7 है ना, एनर्जी कंजर्वेशन से. So now this 2 kpq sin alpha by rq plus t is 2 kp by rq sin alpha. So what is the value of t? mv square by r is nothing but 2 kpq sin alpha by rq. So I can cancel it both. From equation 7 we get this. Equation 7 we have already seen that mv square by r is equal to 2 kpq sin alpha by rq. So I cancel from both sides these two. So what is t? T is 0. So there is zero tension developing in the string. भाई कोई टेंशन है ही नहीं. कोई एक आर्बिट्ररी थीटा में 2 इज एनी आर्बिट्ररी पोजीशन, टेंशन 0. तो कोई भी अदर पोजीशन आप लेंगे, सेम आर्गुमेंट हम करेंगे. तो टेंशन जो इलेक्ट्रिकल फोर्स रेडियल डायरेक्शन में है, जो इलेक्ट्रिकल फोर्स रेडियल डायरेक्शन में है, that will simply be equal to mv square by r. So t का वैल्यू तो 0 हो ही जाएगा. So continuously t will remain 0. So अगर वर्टिकल पोजीशन में आ जाएगा स्ट्रिंग, तभी भी स्ट्रिंग टेंशन will be 0. It doesn't depend on any theta. So this what I wrote. This means the particle is moving in a circular path without any interference from the string. This is very strange. At any position, the role of the string is not there at all during the motion of the particle. This quite fantastic result. That means if we release the particle without attaching to this any string, or string नहीं भी होता, फिर भी क्या होता? It will have moved in the same circular path because string has no role to play here. At any instant, the ER, the radial inward force, is providing the acceleration towards center. So absolutely that velocity is increasing. So also the radial electrical force is increasing, because radial, as the V is increasing. So as you can see here, equation 7 up, mv square is 2pq by r square sin alpha. As alpha increasing, this mv square is increasing, and so also the field in radial direction is increasing. है ना? Same. So such a situation we are observing, so nice. This quite fantastic result. So string का कोई रोल ही नहीं है ये सर्कुलर मोशन में. The radially inward electric force is responsible completely for the centripetal acceleration. No need of any extra force for that purpose. Am I clear? So as the particle enters second quadrant, speed starts to decrease. Then again you can use energy conservation. You can prove that it will come to the dramatic opposite part of the point of the starting position. वो सीधा ऐसे आके इधर तक ही आएगा, इधर तक ही आएगा, and फिर again due to the field pointing down, it will start coming down and like this, come to again here, zero velocity again, then again it comes back. So this goes on repeating itself. not an SHM. C is done satisfy the SHM equation, but definitely a oscillatory motion. So the particle moves in a semicircular path only in an oscillatory motion, which is not SHM. This is what we have found out. So the role of string is not there, was not visible in the beginning. That's why I took the help of the string. But I found that throughout the motion, string has no tensor whatsoever. So string is not giving any force to maintain the circular path. अगर स्ट्रिंग नहीं होता मैं ऐसे ही रिलीज कर देता पार्टिकल को XY प्लेन में, it would have oscillated in a semicircular path. Not in SHM, but definitely some kind of oscillatory motion. It's a very simple question, simple observation. अगर किसने पूछ लिया इसे आपसे क्वेश्चन, by lowest position में tension will be maximum in which position, lowest position, end position, आप बोलेंगे टेंशन should be zero in all position. खत्म. आप समझ में आ गया आपको? क्या बेटा सब एक बहुत अच्छा क्वेश्चन था ना? So you must have enjoyed. So this was a question asked long ago in Scientific American. Somebody must have thought of this question. It is nice. It is quite exciting to solve this type of question. Understood this? I hope that you must have enjoyed the whole thing. And I'll again be back with, if any difficulty here, you can ask me. As I told you, this is my contact. I will be again taking some other topic like fluid dynamics, some very, very exciting questions like this. Small, exciting, which normally evades our eyes. Am I clear? क्या बेटे ठीक ठाक समझ में आ गया? चलो ये देख लो. I'll be back again. So this much for today. Next we'll interact. Next class.